Isabel mentioned, I am Gustavo Castro for the Super Resolution Light Microscopy and Nanoscopy facility, and I'm going to present all the effort and implementation in this data management work that we are done in our facility. First of all, the SLN is the Super Resolution Light Microscopy and Nanoscopy facility. It's an imaging facility where we provide support, we provide training and access to the different users. And we have a good pillar in the develop different microscope to provide orientated solutions, mostly for the biological question that usually cannot be solved with a normal or commercial microscopes. In our facility, in terms of the equipment, we have different microscopes. Among of the commercials, we have a couple of states, Storm, Raman, Flim, and well, as you know, all these, each brand have their own format, and unfortunately, in most of the cases, but fortunately, in most of the cases are bioformat compatible, and it's easy to extract the raw data and metadata, but not in all these cases. Not all the metadata is incorporated in this microscope. Besides of this thing, also each technique provides a different dimension, not only the X, Y, Z, T. Also, there is the channel, the stitching, and hyperspectral. For example, we have the lambda excitation and lambda detection in a continuous way. Also, bueno, there is this stitching, and well, this start to make in a real complex way to manage the data. On the other hand, as I mentioned before, we developed the different solutions for biological questions, and this in this direction we are developing different microscope, multiphoton, adaptive optic for ophthalmoscopy application, structural illuminations, and in the end we have different light sheet fluorescent microscopy, and here other but similar problems start to appear. As we are developing on our solutions, we depend on the cameras and the different detectors. So each camera, also each brand, have their own format file to store the data, and also there are many standards that depend on the community that they establish, which is the standard. So in major of the cases, this was managed on multiple dimensions and tried to manage all this large volume of the data. One of the solutions that we want to implement it is the solution that we need is to start to develop a data management plan. This data management plan, well, I will not enter into the details because this topic has been extended, mentioned it before. So everybody knows the benefits to have to follow the FAIR principles. So the major problem that we start to have is the manage the multiple dimension and the generation of the large volume of the data. So what's in this moment when we meet at the PIC, the Port Information Scientific, this is a scientific and technological center that provides support the different research groups that require strong computational resources in storage and in the analysis. So in 2021, we applied for a grant from la Red Española de Supercomputación, and we granted at the peak this 350 terabytes for 5 years. So we can do this grant, transfer all the data that we are generated to the peak. Do this grant. And later we apply for in the 2022 for other grant. This is called Plan Nacional. When one of the objectives here was develop an automatic pipeline for connect the microscope that we are generating in the project and transfer directly to the peak. So Well, the first thing that started to appear was the metadata structure, because to transfer all this data and to be fair and all this one, we need to be really consistent in the metadata structure. So we develop basically a JSON format to help us to manage all this data, and it's inspired in the in OME standards. So as all the standards in OME, this is the reference. Include the pixel size, the dimension, the creation date, the details, particular the details of the instrument, and this is related with the previous talks, and also include the we implemented this others ID as the project experimented, project name, all the information that we consider that is necessary to have an traceability of all the data. This is basically the structure of the project. So basically, we have the image detail, instrument detail, and the project detail. In the instrument details, we have for each microscope that we develop a microscope database where we include a version and the different configuration that we can have for this microscope. Even this is if we have a new camera, if it's not the same camera as was mentioned in the chat, some cameras have even if it's the same camera, the same model, and everything, a little bit different sensitivity. So it's better to have this traceability in the microscopes. Also, we include the project details as the name, institution, project, everything is referent and ID. In the part of the image details, we have the location in our clouds where we are storing, the checksum to see if the transfer status is well done. Also, we have a sequential code, the transfer status, bit date of the images, and of all the details that we consider relevant. And as in the image dimension, as you know, X, Y, Z, T, stitching, rotation, mode, channel, that is one special dimension that we consider that can be the combination of the previous one. So now we have a real established protocol for the facility. When a new project starts, basically the first thing that we do is included all the information that we can do in our database, the number of the project, description, agreements, all the relevant documents that we can get of this project, we include it in the database and we assign an ID of this project. And the same for the users and the institution if it is not included in our database. And the second part that is we encourage a lot of the users to do it, but now at least for our facility is mandatory. We store all the experiments in our project in this way. So we establish this part. So the project is the name of the project, the day that where the experiment was performed, some tag. This is completely freedom. It's only to help to the user to identify their own experiments, and the status of the data. Here allow for different levels to have an traceability in the data that where they come from, and finally the file name. In the end, once all the experiments are finished, we are using a script Python, the JSON file that we are that we created to transfer the data to the peak. How we do that in our microscope is quite easy because we are programming, so we can generate a file, but it's more or less the same for the microscopes for the commercial microscope. And together with the file that with the raw data, we are creating automatically the JSON. And we copy directly this data to on own clouds, and later remotely we can using the script Python in the SLN in our own servers, we can create a copy of this JSON file in a special cloud that we call Wormhole. And this special cloud is an bridge that making a connection between the peak and or servers and or clouds. So at peak, they routinely check which is the JSON file that are new. And in the JSON files, as you remember, here we have the information on where are stored all the raw data. So they can access to on cloud and copy directly the JSON files to the JSON file together with the raw data in the computing farm that at peak. So later we can access to this data through a Jupyter notebook. So in this way, we can access directly to, in the classical way, in a local, more or less local way at ICFO, or we can process our data through a Jupyter notebook directly in the peak. So how do this one? As I mentioned, in our microscope, we develop, we control our microscope using LabVIEW, and the first screen that appears when we run the software is a screen that recognizes directly our username, or we can tag the username in the case that we are not in our session. And this directly indicate which is our ID the user and ID of the group and the project. Also selecting the project, once we select the project that we are working, this project will be, the ID of the project will be appear here. And until we select everything, this will be kept here. That's in another word, this cannot be skipped. So, and this is every time that we turn on the microscope. So the second part, this information is passed to the advanced settings, and it's filling automatically all the in all the ID. So the configuration database of the microscope fill automatically all the fields that are empty, and we can choose the configuration that we are using in this moment. And bueno, this automatically is transferred and is create the JSON file when we acquire any images. So in the end, we create an automatic pipeline. This is the pipeline that we are using until now to transfer our data from our facility to the peak. We are using this JSON file to help us to manage all this data. Is file format free because this is not dependent of the raw data in situ. So we can use the same JSON file for the commercial microscope or for own solutions, and allow to have a multidimensional freedom also. Bueno, basically this is all this part of my presentation. Thank you. Thanks especially at Nico and Eric and the big people to help us in all this part.